All right, so we are going to multiply two binomials here. Binomial is nothing more than really something with two terms, I guess is a basic way to describe this. Um, and so a term is something that's separated by a plus sign or a minus sign. So here we can see inside parentheses we have 1, 2, 1, 2. So these are two binomials. And when you multiply binomials, really any polynomials, so any string of multiple terms, you basically want to distribute. So you want to make sure that each term is multiplied by each other. So I'm going to take this 2x and I'm going to multiply it by 3x and negative 7. And then also take this 5 and multiply it by 3x and negative 7. So one way to think about this is to say, all right, I have 2x, and I'm going to multiply this by the whole binomial, 3x minus 7. Then I'm going to take the positive 5, and I'm going to multiply this by the whole binomial, 3x minus 7. And so now distributing in one term is a lot easier than distributing in two terms. So here I'm going to have 6x squared minus 14x plus 15x minus 35. The final step here would be to combine any like terms that I have. And I notice that 15x and negative 14x can be combined into a positive 1x. And then I still have this minus 35 on the end. So that is my completed product. I can use this for any binomial. And you don't need to just, well, there are some special cases that I'm going to show you right now. But for these special cases, you can just fall back to this at a very basic concept. Here's the first one. It's squaring a binomial. So here I have this 2x plus 5, but it's squared. Now, a lot of people will think, all right, well, this is going to be 4x squared plus 25. However, you can't distribute an exponent. It doesn't work like that. I can't just say this is 2x squared and this is 5 squared. Because remember, this is going to be 2x plus 5 times 2x plus 5. And so we would get 2x times 2x plus 5 plus 5 times 2x plus 5. And so this would give us 4x squared. 4x squared plus 10x plus 10x plus 25. And so this would give us 4x squared plus 20x plus 25. You would have this middle term there, which frequently a lot of people forget when they do this improperly. Now this is good, but this looks like a lot of work. There is a shortcut here. It's where you square the first term, so 2x. You square the last term, 5, but then there's going to be this middle term here, which again is one that a lot of people forget. What you do is you double the product. Double means you multiply by 2. So I do 2 times 2x times 5. 2x squared is 4x squared. 2x times 5 is 10x. Times 2 is 20x. And 5 squared is 25. Look at how easy that is. The general formula for this would be if I have a plus b squared, this equals a squared plus 2 times a times b plus b squared. In this example here, the a is 2x, the b is 5. So a nice little trick to help you multiplying this out so you can do this in a matter of seconds as opposed to working this out. The next one is when we multiply what looks to be the same binomial. The only difference is we're adding and subtracting. We call these two binomials conjugates, but that's not real important here. So when we multiply these together, again, let's do this the old-fashioned way. So I get 2x times 2x minus 5 plus 5 times 2x minus 5. So if I distribute this in, I get 4x squared minus 10x plus 10x minus 25. Notice here, these middle terms cancel out to 0, so I get 4x squared minus 25. This is actually called a difference of two squares. So the shortcut here, when we see that the first term is the same and the second term are opposites, positive 5 and negative 5, what we can do is we can square the first term, so 2x squared, and minus the last term squared, 5 squared. 2x squared is 4x squared, 5 squared is 25. That's it, we're done. This would, in a general case, if I multiply it a plus b times a minus b, this would look like a squared minus b squared, which again is a difference of two squares. So again, a nice little helpful shortcut where if you see this, you can easily and quickly find the product as opposed to working it out and possibly making a mistake. But if you don't like that or squaring a binomial, again, you can always take the longer method and just distribute this, this binomial into the other binomial to multiply.